Welcome everybody. We're gonna give another minute or two to let people sign in. Looks like we've got about half the people registered already in, so we're just gonna give a couple minutes. Y'all should see the opening slide and Eric's face this nice early morning. It's not that early. And if you can't, go ahead and type me a message in the chat. But otherwise, we'll just wait another minute or so. It's 10:02. I don't want to wait too long because Eric has a lot to get going, but let's give it another 30 seconds. Thank you for your patience.
A quick question, Katie. Can you hear me?
Yes.
Do you start the recording or should I?
I did.
Okay.
Yep.
I got an error message when you did.
Mine is recording.
Okay.
Yep.
Good. Fair enough.
All right, it is on the let's see, waning side of 10:03, almost 10:04. Let's get going, Eric. Welcome everybody to our network lighting controls series for sort of special applications. This one's going to be warehouse, and you see Eric right there. He's going to be your presenter. And if you want to go in the next slide, Eric, I will do sort of our housekeeping stuff. My name is Katie. By the way, I'm not usually presenting these things, so bear with me if I miss anything.
And let's see, there we go.
Oh, good. Okay. If you haven't attended one of our courses yet, you all will be muted, but there's a chat feature over in your, well, there should be. I just heard from Sean, maybe he doesn't see the chat. I'll look at that in just a second, Sean. There's going to be a little online poll every, well, it's probably a little more than 10 minutes or so. There's about 6 different polls, and we'll pause to take questions then. You can type those to us in the chat and Eric will answer them. After class, as soon as the webinar ends, actually, a little survey will pop up. If you take that, please give us some feedback. This is the first time that we've done online courses, so any feedback you have for our next series starting next year would be excellent. And then within the next few days, a recording of this, it's already being recorded, as well as the slide deck that Eric's presenting will be posted on our webpage. There's our email if you have questions later. And just a reminder, the Lighting Design Lab is powered by Seattle City Light. We're Seattle City Light employees, always have been, always will be, as long as we're employed with Lighting Design Lab. And we are proud to be part of City Light. And for this webinar in particular, we got some help from Nia and the Better Bricks Initiative. don't try to click on the logo right now. When you get the PowerPoint later, you can click on that and learn more about what they do to support us and lots of other initiatives around energy efficient buildings. And just in case you're not too familiar with us, we have three pretty distinct but also intersecting groups of people we work with, customers we work with. The building users, the people who build and maintain buildings, and the people who design them. And there's probably in this group a few of each of those groups. It's kind of cool to hear questions from all the different perspectives. And as well as the education that you're taking part in today, we are involved in technology evaluation. Recently did a, oops, Eric, I can see another window showing on top of that. There, it's gone.
We good?
It's good. We helped out with evaluating parking light sensors for, beginning of this past year. We've got lots of tools and resources that we have on our website, or you can contact us about. You know, with COVID, our mock-up room isn't something that we can access, but that's something we've done in the past. We'll do in the future when it's safe again. We can do sort of a virtual assessment or consultation too, if you're interested in that. And information aggregation. We try to bring all of the newest and best information to all y'all when we can. And
there we go.
There we go. Without further ado, let's let Eric do his thing.
All right. Thanks, Katie. Well, I want to say I'm glad everybody is here. We've got maybe a few more attendees coming, but yeah, so this will be a little overview and a little bit of a drill down on some network lighting controls, so-called NLC, for warehouse. And we'll get started. So I think a lot of you probably have taken classes from me, and I appreciate that. I've been at the lab since 1995. I'm kind of like father time around the lab. And, you know, I've been doing lighting for over 30 years. And that involves all kinds of things, whether it be roadway lighting, certainly warehouse lighting, lighting for schools, residential lighting, you name it. And we've been teaching classes, doing consultations, writing articles, etc. So it's a joy. I love lighting, and I'm happy to, you know, be able to learn new things and share them with other people. But, you know, enough about me. I try to know a little bit more about the group here and what you're hoping to get from the class. So our first survey will be to tell us a little bit about yourself. You know, possibly done lots of lighting, but know very little bit about network lighting controls, or maybe you know a lot about network lighting controls, but don't know much about warehouse lighting. You could be new to the whole thing and just start trying to learn what you can. And honestly, some people know about both of these things, and they just need some continuing education credits, and that's fine. We're happy to have you. You know, it's also possible you're just in a COVID meltdown and you're taking anything at all possible for distraction. So just let us know where you stand. And I think the polls are open.
It's open, collecting responses.
Excellent.
Just going to give it another second and Get your vote in. Closed. All right. Eric, can you see the responses over on the right panel under polls? Okay, so you've got about half the class. They want to learn what's new. And then after that, about 30%. Oh, say that.
Is that C or?
Yes.
Okay.
And then there's, after that, about 30%, lots of lighting, A. And then a little over 10% each just want some CEUs and new to lighting.
Cool. Well, great. Well, we're glad to have you, whatever reason that may be. So I thought this was interesting. You know, lighting can be a really big part of the costs of particularly a warehouse facility. If you think about it, it's a big open space often with, you know, maybe not a lot of other you know, unless you're running maybe a cold storage facility where a big cost is your energy is towards cooling. You know, lighting can be a big percentage of that, and if you can chip away at those lighting costs, you're chipping away at your operating costs significantly. And certainly we've seen with the LED revolution, a big piece of that is just going from what would normally be metal halide to LED. But you can save an additional, you know, 15 to even 30% by using controls. And we'll see how, particularly if you have a very primitive control strategy, adding controls and even network lighting controls can really lean down those costs. So what we'll try to accomplish today is understanding common lighting control strategies. So we're not going to spend a lot of time on that. This class is building on some classes that Sean and I think Armando have done on controls. But we're going to review some of the fundamentals of network lighting controls and then review how controls relate to current lighting health and light and health research, touch on that, and then review some applications and look at some products in specific products. So, you know, people think of warehouses and they think of just, you know, big aisles of racking, high racking, or even just low racking, but it's just big storage. And certainly that's a part of it, but you know, warehouses are complex facilities, just like many other facilities. And each of these areas can have, can benefit by controls and can benefit from tailored lighting approach. So you've got shipping and receiving, certainly the storage, whether it be aisle storage or open storage, those would be handled slightly differently. Loading docks, you've got maintenance areas. Then there's offices. Most warehouses have some kind of office. Sometimes they're rather large. Sometimes the corporate headquarters is located at one of the major warehouses. Then you've got obviously utility areas like restrooms and showers, and then perhaps customer areas where maybe people come in and are going into boardrooms, meeting rooms, or even just lobbies and talking directly to the staff. So again, complex facilities. This is a controls class, but I think we're going to do a brief overview of some of the high points of what modern warehouse lighting might look like, just to touch on a few things. So, right, obviously, almost all new construction today lighting is being done with LED. I can think of maybe just a few niche areas where you might use something else, but for the most part, it's LED all the time. And that's a good thing, especially new LEDs. Modern LEDs are extremely flexible. They have really save on maintenance due to their long life. You can do things with LEDs and color that weren't possible. Of course, they can be a white light source, an excellent white light source, and they're not all the same. And we'll look at this a little later. They can have somewhat poor to excellent color rendering, and you want to make sure you probably don't need the highest quality, highest color rendering for most warehouses, but you also don't want poor color rendering because speed and accuracy are critical to good operation. LEDs, how they've impacted architecture has been rather profound. The fixtures are smaller and lighter weight. I don't know how many of you have actually picked up a old style high bay metal halide fixture, but they're very heavy, and that's not a huge factor, but it does factor into building design and some other things. Higher, more efficient, again, with better color, certainly more flexibility and control. If we look at metal halide as the baseline, there was almost no control with those products. And even with fluorescent, high bay fluorescent, we have improved control over that. Longer life, which results in reduced maintenance, better optics, and some of the, as we'll touch on, some of the spaces in warehouses are rather unusual and rather demanding optically. Dimming, very easy. Even fluorescent, you could dim, but it was a bit of a challenge. And with LED, it's much easier, potentially better integration into other control platforms. With that said, it's still somewhat of a new and emerging technology. They're getting better all the time. They're changing, so there can be a little confusion. And then, of course, we can manipulate the color for a couple of different reasons that we'll look at as we go. So this is from the IES, the Illuminating Engineering Society. They have a recommended practice, RP7, relatively recent. RP came out in 2017, and it's for lighting industrial facilities. And this class doesn't focus on that, but it does have a section on warehouse. And, there's some good information in it, but, and I won't go into a lot of that. But one thing I did think was interesting to point out was a couple of little excerpts I've included here. Fixed racking, because of the geometry of the aisle space, which generally yields a room cavity ratio higher than 10. So when you're doing calculations, whether it be with software, usually, you need to have a room, what they call the RCR. And what that means is it's a tall, narrow space. And so it has a lot of wall and very little ceiling and floor. It's almost like you were standing in a phone booth, if anybody remembers phone booths. So as a result, the typical calculations that you might use for more like an office or a more normal dimension space can yield some results that are deceptive and aren't necessarily relevant. So the typical lumen method of average illuminance is not really affected for a warehouse application. Another thing that they talk about, which I thought would be useful, is that the spacing of the luminaires can be increased when the luminaires have a substantial uplight component and the ceilings have a high reflectance. So I'd be a little cautious here on two counts. One, usually indirect lighting is often not quite as efficient just in terms of overall delivered light, unless you have a very highly reflective and usually uniform ceiling. And often, even if you have the ceiling sprayed out white, it often has a lot of structure up there that you wouldn't typically find in an office or a classroom. So you need to be a little cautious of that. But that said, yes, having an indirect component can help with contrast ratios, so you don't have this bright white glary fixture against a dark background of an unlit ceiling. And it can also help with your spacing. You don't need to have them spaced quite as closely. So those are a couple of takeaways I thought that might be useful in this context. You know, how much light do you need? The IES, again, from the IES handbook, they have average maintained foot candles, and they have a range for different things. I just excerpted bulky items, things that related to a warehouse, cold storage, aisles, etc. This is actually from our website, Lighting Design Lab. We have a little foot candle guide that you might find useful. You can find that in our resources section. But at any rate, so we have the horizontal foot candles, but they also have vertical. And of course, vertical is critical when you're looking at particularly the racking areas. Those are, you know, reading labels on a vertical surface like the end of a box or the end of a racking. It is particularly important, and it's not so much horizontal. And so they have ranges and targets, lighting targets for that. These are in foot candles, by the way. So that might be one way to determine how much light you need. Another, of course, is there's going to be state and local codes that might come into play as far as minimums required. Another would be health and safety requirements. OSHA might have requirements that could supersede. I will say that usually the IS recommendations take into account these things, but it doesn't hurt to check. You know, and another thing that might be relevant is often an owner is going to say, well, I know that it's, you know, minimum of 20, say, foot candles, but I want 40. Now that could be a discussion you have, but, you know, or they may say, well, we really like our existing lighting, and so when we do this redesign or retrofit of our big facility, we want it to be the same amount of light. So you need to go in there and see how much they've got. Now maybe low or maybe high, but at least that gives you some sort of reference point to how much they need or at least want. And so having a light meter would be relevant there. How much light will you get, of course, is a calculation. So you have an idea of what they want or what's required and how do you get there. So, you know, here's a product, a high bay fixture by Lithonia. You know, this one product has many, many variations. So which one do you choose and how do you know what to pick? And I thought it was interesting. You need to be a little careful. I'm just looking more closely at this product. So if we were to pick this 30,000 lumen fixture, let's say, and if we go to a 4,000 Kelvin, so it's a fairly neutral, cool color, 70 CRI, we get close to that 30,000 lumens, 29,000 and a half or so. if someone comes along and says, well, we really want higher color rendering because we've heard that's better, and we think we want a warmer color for whatever reason, you can't just substitute. You can't just go to the 30,990 CRI, that's the color rendering index. You'll lose almost 30% of your light. That becomes an 18,000, almost, just below 19,000. And the efficacy changes. So the 4070 CRI is 125 lumens per watt. The 90 CRI product is 80 lumens per watt. Now, it's possible that you need that higher color rendering. Maybe, again, you're on some sort of high-speed production line where you're picking things quickly. Maybe it's pharmaceuticals, maybe it's electronic components, where if you make a mistake, it's a real life-threatening problem. So in that case, you just have to go with the higher color rendering and know that you're going to, your energy savings won't be quite what it could be. That's just the cost of doing business, if you will. Additionally, there's a little bit of an optical change when we go from this product to this product. We go from a, this is the ACCR, which is the acrylic, and then we go to the DALRN, which is the aluminum reflector narrow beam, and you actually get a little bit of a as you change here to different optics, your light levels, your output changes. So that's just another thing to be aware of. If you make a last minute change, you probably have to go to a recalculation and maybe you need more fixtures. So just don't get caught up there. I like to include this. This is all the, not all of them actually, but all I could fit on one page. All the different photometric files for just that one fixture. And someone said not long ago, isn't lighting getting easier now? It's just LED. Well, not so much. There's still lots of possibilities, lots of places you can kind of get caught up in a little trap if you're not careful. So anyway, all right. So moving on to controls, though. Network lighting control systems. I mean, that it's not just one size fits all. There's so many different possibilities out there. It can be a little overwhelming. And one thing we're going to try and do in this class is explain a little bit about some of the systems, but also maybe set your mind at ease to show that there's a lot of commonality between them, but you also, you can choose the one that you think is going to work best for your situation. We've got some that are fairly simple, some that are much more complex. Generally with the complexity adds more possibilities, more variations. So it's, you just have to decide where you need to be. Most of these network lighting control systems are going to be a distributed system. So that means that they're going to have controls in one area, user interfaces. There's going to be sensors going into those same zones. So we have Z1 here. We have a user controller at Z1. Those are going to be all connected, whether it be a sensor or a manual user input. They can be a standalone system, or they can be integrated with other types of building systems. We'll find all of these, even the simplest ones will be scalable to some degree. They can incorporate some kind of scheduling, time scheduling, date scheduling. Though if that's important, you might want to be sure that you get one that has more ability there. Again, we'll accept input from various devices and sensors. All are very flexible. And, if you want to incorporate it into other building systems, that's something you need to be sure you can do in advance. Most of them will, but there may be workarounds that you need to be aware of. Then we see luminaire level lighting controls, right? So here, if we go back, this is a system where you're putting in components, usually from one manufacturer, but not always. Here, everything's baked right into the fixture for the most part. Then the various input devices, other than the sensors that are built into the fixtures, there might be wall controllers. Those would be part of the same manufacturer's product, and then you're setting it up with usually some kind of handheld device. They're simple to install and specify. That's one of their big selling factors, if you will. You can get highly granular zoning. We'll talk about zoning a little later on. But in a sense, each fixture is its own zone. Usually capable of occupancy and daylight. Smarter systems, if you will, can do more things. They can have other sensors, maybe CO2 sensors, or other types of things that would be inputs. We'll look at those. Pretty much all of these will require some level of commissioning. One of the promises of the luminaire level lighting controls is that out of the box you can just kind of put them up, and once you sort of turn it on and set it up, it's ready to go. But to maximize your savings, you're going to want to probably tailor it to some extent. Then we have power over an Ethernet. This isn't brand new, but it's relatively new. And this is a case where each fixture, each user input home runs back into a little controller area. Each fixture is actually powered by the Cat 6 or Cat 5 wire. So you're basically running a low voltage wire, and that's one of the things that wasn't possible before LEDs. LEDs cut your power consumption so much that it is possible not only to control them, but also to power them with these low voltage wires. I think for high bay applications, it's fairly limited, just in that these fixtures in a high bay space are usually fairly high power, and they would, for the most part, it would be one fixture for every one run, if you will. And so that would be a lot of cabling. But it is again, it's something we're looking at, and we're seeing it emerge in a range of applications. And so it's possible we'll see them coming into storage, maybe not large high bay storage, but warehouses, but maybe other types of storage application situations. Lots of product out there. We're seeing all the major manufacturers are either building in-house or partnering with manufacturers that do controls. And so we're seeing a lot of, like I say, a lot of partnerships. And we'll touch on some of those as we go, but as you can see, we've got pretty much a lot of the major players here. It's interesting that Cooper is back to Cooper. And we've got some other, we've got Lutron certainly in the game, Digital Lumens is another player, and Acuity, of course. So yeah, lots going on in this space. So the systems out there today, just to sort of recap and kind of touch on them, are going to be a distributed. Wireless is one thing that we're seeing more and more. I think there's often going to be some wired components there, and certainly most of these products can do a fully wired if that is in fact what you either need or want. More complex, more capable, less complicated. So the complexity increases, but often the simplicity is also increasing. Costs are coming way down, and that's been a roadblock over the years. Easier to install and commission, and so in general, they're just getting better. And so it's really worth taking a look. All right, we're going to do a little pop quiz. So the polls are open. And so here we've got, what are some of the benefits of Luminaire level lighting control systems? And that would be and pick all that apply. Highly granular control, easy to install, easy to say, basic programming out of the box, and ensures compatibility of components. We'll give it a minute here.
People are voting. So important to vote.
Yes.
Might be voted out for a while. I'll give it another few seconds and then I'll close it. And then Sean reminded me there's a share button, Eric. So I think when I close this and hit share, everybody will be able to see the answers.
Ooh, all right, let's find out.
I know, experiment. Okay. All right,
Share.
looks like everybody's voted. We'll close and hit share. Can you see it, Eric?
No.
The attendees can see it, but you can't see it. Oh, that's a bummer.
What?
So we've got, Eric, 94% of people said highly granular control.
Okay.
88% said easy to install. Nobody took the bait. Nobody took the bait for easy to say. 88%. This adds up to more than 100. Oh, it was multiple answers allowed.
Yeah. Some of the.
Your basic pro the box, and 3% said ensures compatibility of components.
How many? 3%?
63. So
63.
Fewer voted, fewer checked that box.
All right. Well, so okay. I mean, yeah. So I think the ensures compatibility of components is one of the strengths of these. And let's just say it together. LLLC. Did I get that right? LLLC. I had an extra L in there. See, that's so easy to say.
So many L's.
Or I prefer Luminaire level lighting control. It just rolls off the tongue. But at any rate, they do ensure compatibility of components because they're all coming from the manufacturer. They're baked right into the fixtures. So when you get them, they're all there. They're all, they're all ready to go. So that should be 100%. Basic programming, and there is some basic programming when they arrive. Usually, you just turn them on, and often they'll kind of do some occupancy. You might want to change some of the parameters, like the sensitivity or the lag time, but and then daylighting control often is right there, ready to go. Again, you might want to set your targets, and we can talk about that in a minute. Yeah, so yeah, the only one that wasn't, I'd say, was questionable is this C. All right, moving on. So typical control strategies, and some of these are, not much of a strategy. One is manual switching, and honestly, I will tell you, in a warehouse, that may be one that you'll see still, where you're coming into a space and you just want to actuate the controls manually. Manual dimming, again, possibly, and certainly some of these would apply in office areas, as we'll see. There's a whole range of spaces, but Scene and preset control, again, probably not quite as important for a warehouse environment. Occupancy sensing, definitely. Vacancy sensing, definitely. Daylight harvesting for sure. Task tuning, we'll touch on that for sure. Time scheduling and astronomical scheduling. Yeah, all of these are relevant. Let's go through some of them briefly, some more briefly than others. So yeah, line voltage switch, manual switching rather. The oldest types are line voltage, but we see, especially in big facilities, you might be running low voltage actuators to some of the exits and egress points, and then they just turn on big banks of lights. And that would be more of an old school approach. Zones or groups, so we may be having areas that are in a zone, small zones, in maybe shipping, receiving would be two different zones, but you might group shipping and receiving into one grouping for certain kinds of things. It's just a range, simple to design, easy to understand, and may not meet codes. We're seeing less and less allowance for manual controls, at least as the main control device. Manual dimming. Again, that certainly has its place in certain types of facilities, maybe a little bit less in a warehouse, but the dimming can be line voltage, where you're having dimmers that are just controlled by line voltage. More likely it would be low voltage remote dimming, where you're controlling a large dimmer that is off in some other area. Network systems, again, zones and groups, simple design, easy to understand. Most people get dimmers, and users do like to have a certain degree of control, so that can help for productivity. Preset scenes, somewhat less seen in well, that's not necessarily true. You know, we think of these as presets and scenes as being something you would have in like a boardroom, but really what we're talking about is zones and groups of zones that all act together for various inputs. And you could have a scene that might go from day shift to night shift, and it might be a slightly different scene. Maybe at certain times the receiving is done, but the shipping isn't done. And then you've got maybe the office is closed, and so you can shut off the lights to that section of the building. And so some of those could be considered scenes. So it's not without some use. You really want to have engraving so that people, you know, we sometimes will see a controller with these scenes, and it's like, what do these mean? And it makes sense if you've got one or two people who are using it all the time and they know what they are. But if you've got various users, you want to have something on here showing what these various scenes mean and what they would do. Otherwise, it just creates confusion and people just quit using it, or they use it incorrectly. All right, so I've included this little video that my colleague Sean put together, a very clever little video to kind of talk about some of these things. So I'm going to see if it's going to run for us here. Let's just try it. It worked in all my. Here we go. So we have on-off controls, so we can have all the lights come on manually and then go off manually. And that would be your basic switching. Now we could have manual dimming, where we have one zone that goes even down dim it back up again. Turn it off again, so that would be manual dimming. We can do that with a single zone, or we can do pull them all together. As needed, and then of course turn them off. You'll note that all this is being done wirelessly. Okay, so this is a system that's, now we have preset scene control, and so we can dim down. One scene is all up, everything down. Another is certain lights go off, certain zones, and others stay on, and then we can of course turn everything off. And system, but other products have a similar effect. I will say that Sean agreed to let me use this slide if I would mention that he's considering a sideline as a hand model, and so he'll be pursuing that later. Okay, that's not true. So the sensing, some of the input devices, obviously we've all heard about occupancy sensing, hopefully. And that's where you walk into the space and the lights turn on. And then when you leave after a certain period of time, it could be 5 minutes, it could be 30 minutes. It depends on either what you want or what the code allows. The lights will automatically turn off again. And, you know, there may be a little bit of hesitancy for using some of these sensors. Some of the older ones maybe didn't work so well. The new ones are certainly much better. Often the occupancy sensors have been supplanted by the vacancy sensor. We'll touch on that in the next slide. But we would be seeing occupancy sensors primarily in public type spaces, corridors and stairwells, toilet rooms, warehouses, parking garages, and site lighting, places where you don't necessarily want or can't, it's not practical to have people actuating the lights. And I guess now's a good time to say that a vacancy sensor, well, let's just go to that page. A vacancy sensor looks identical, almost functions identically to an occupancy sensor, except it requires a manual on. So instead of walking into the space and having lights come on automatically, you have to actually turn them on. And again, these make sense for areas like break rooms, a storage area. Now, a storage area is different than a warehouse. A warehouse is a large space with various entrances and exits, many users at a time. Whereas a storage area would be a smaller room, usually with one door, maybe two doors, and you can have a sensor or a switch at each of those locations. And so then it wouldn't be unreasonable to think that someone would walk in, they'd turn it on just like they turn on a regular light switch. And then once they leave that space, after a period of time, the lights will go off. There's a lot more savings that can be had in that for that kind of thing. Break room would be the same thing. People come and go. They tend to forget to turn off the lights. Might require a little user training. Sometimes the button isn't exactly like a switch that they're used to. That's good and bad. And I would say that you know, when you're looking, especially if you have a large facility where you're going to have a lot of these, get a sample of what one of these things is like and see if one is going to hold up, and two, you know, over continual use, maybe by indifferent users who might just sort of bang the thing. How rugged is it? And how intuitive is it to find the button? And that might be something that you'll either have to go to a different product or otherwise, like I say, talk to the users about. So yeah, moving on. So with the sensors, and this is true for most sensors, but particularly occupancy sensors, and particularly passive infrared, which we're usually going to be seeing in a warehouse application. You have different patterns. So obviously a long, narrow pattern would make sense for a long, narrow space, which you typically find in a corridor, like a warehouse aisle. And then you have different sizes, and you wouldn't think, well, just get bigger's better, right? Well, that's not necessarily true. If you've got a maybe a shipping area, shipping and receiving, that's next to another space, maybe near a corridor, let's say, where people are coming and going, you don't necessarily want the lights always coming on in the maintenance area, where it maybe doesn't get a lot of occupancy every time they just walk over to the break room or they go to the restroom. So having a narrower beam in say the maintenance area would make sense. So you're not getting lots of false triggers. So yeah, just bear in mind that you could get different sizes and different coverage patterns. Task tuning or high-end trim is something that really could be used quite effectively, particularly in a warehouse setting, and we'll talk about it throughout. But essentially, it's where maybe if the light, here's an office. I couldn't find a good example for a warehouse, but let's say this is your an office, or it could be the warehouse area, where just out of the box the lights are this bright. Well, that's 20 to 25% above your target light level. Well, you can just sort of dial it back a little bit, and now it hits your target. It maybe is a little less glary, a little less jarring. It certainly saves energy. It can also save on maintenance, since the fixtures are not running at full output, if you will. They're running a little cooler. And yeah, we typically will see spaces where you might have the aisles, maybe need the full output of the lights, but maybe in the open areas where you get more contribution from other fixtures, maybe you've got some low racking or low open storage. You can trim off 20% or more of the light and still get the same light level. Yeah, it can be a powerful tool and a good way to save energy. And of course, you can't do that unless you have, say, a network lighting control system. Times we know all about it, is where you're scheduling the lights to maybe the business closes at 6 o'clock, and you want the lights to do something, maybe go off all the way or down considerably, maybe by 8 o'clock or even 7 o'clock after most people are gone. But other times you can do scheduling, or maybe you're closed on Sundays and you want to make sure the lights don't come on except for a few safety lights. But other times you could do scheduling. You could put a photocell here, but you could also just say every day at 9 o'clock in the morning, we're going to have enough light in this loading dock, and just have the lights turn off. It could be on an astronomical time clock where they, in the winter, it stays on a little longer, and in the summer it goes off maybe at 7 o'clock. In the winter, it might stay on till 9. So sometimes the time scheduling can be a way to maybe it could be a little simpler rather than having a photocell installed either somewhere or put onto the fixtures. Yeah. Okay. So daylight harvesting, using photocells, using photo controls. you're going to, obviously a well daylit space is going to maximize your savings, and we'll touch on that a little bit. This is a sun optics system where we've got fixtures, skylights in this space. It's a little hard to see in this picture, but these lights are off, and you're achieving you know, a good light level. But again, you have to be, you know, the better your daylit, your space is daylit, the higher the savings will be. And honestly, you'll probably have better lighting if you have a well daylit space. You know, there's been this trend, and even in grocery stores and even warehouses, places where you don't want to dim because it's been costly and or not practical, so you just have the fixtures turn off. They go from on to off, either in groups or all together. And one of the disadvantages there, you know, so say your target light level is 30-foot candles, and you program it to say, well, we're going to have it go off when it is 2 times our target. 60, when the daylight reaches 60-foot candles, we're going to turn off the light. So that would mean you'd have, you know, depending on how you figure it, you'd be 30-foot candles in the light, 60-foot candles in daylight. So you might be as high as 90-foot candles, and then you're going to have the lights shut off. Well, you're right there, you're going to lose 50% or 30% of your light. And you're still twice your target, but people notice that. And for a few minutes, it's going to seem dim. They're used to that brighter light, and then boom, the light suddenly goes away. It's distracting. It can be annoying, and they'll also feel, because of the way the eye and the irises work, it'll seem dimmer. So it's not a great plan. If people are really gung-ho about it and they're eager to save energy and they know about it and decide they don't care, that's fine. But honestly, with LEDs today, they really are all pretty much dimmable out of the box. It's kind of hard to get a non-dimming driver for LEDs. You're better off just dimming. Newer control strategies, tunable white, circadian lighting, we'll talk about those. Specific color tune adjustment, so you can either tune to a given color, or you can play with your spectral power distribution. You know, these are really sort of 2 separate things, but they can affect mood, alertness, and honestly, before we had LED lighting, we weren't really able to do this from a practical standpoint. So tunable white is more of a, it's a way to manipulate the lighting as you're changing tasks throughout the day. This is obviously a classroom here, but it could be, you know, maybe after breaks, the lights go up to, you know, 6,000 kelvins and a little brighter, and then maybe as things progress, you know, half an hour after the breaks are over, they've settled back into 4,000 Kelvin and a little bit dimmer. Maybe after lunch, it's even a little longer, or you're doing, you know, just places where you can manipulate it to change the mood, change the feel. Maybe different tasks are going on that make it appropriate to change the lighting and the light intensity and the light color. So LEDs are really able to do that. But another thing that we talk about, and it's a different thing, it's more of a physiological change, is circadian controls. And this is a study that was done in Sacramento at a senior care facility with the high degree of Alzheimer's patients or patients with dementia. And, you know, frequently what happens in most healthcare facilities is the lights stay sort of bright in the corridors, and they say a certain, you know, sort of a neutral white, bright all day long, and really well into the evening, and maybe late in the evening, the lights switch down to a considerably lower level. Maybe they turn off every other fixture, or every 3 fixtures, but the color doesn't change, and it's fairly abrupt. So this was a case where they had a daytime look, then they had a morning look, and then they had a nighttime look, in a way to mimic what we would typically have in a regular day. The lights in the nighttime area are almost all the blue is pulled out, and they're very dim. And just to see how this was going to affect the patients. It's a really interesting study. I recommend you take a look at it. We're not going to get into the details here, but you can Google that and find out. It was fairly successful. It's fairly compelling. Just as a concept, what we're finding. So maybe I'm going to jump ahead here. So what we see is daylight changes throughout the day. It changes color, changes intensity. And so as a concept, you could imagine in a warehouse, this is I think a pharmaceutical warehouse, you might have morning period where it would be fairly blue, maybe 110% of your target. And then as the day would progress, you would get down into a more neutral color and maybe 90% of your full output. And then once you got into the evening, it would get even warmer still and dimmer still. So again, this is just maybe for a concept. It wasn't vetted scientifically. I just pulled this together, but that might be how something could go in certain kinds of warehousing, where you are interested in a circadian effect. Again, to try and mimic a day. I will say that I'm not sure quite how that ultimately would go. This is, for many of you know the lab, this is our classroom. Back when we were meeting in person, we had classes here, and we had color tuning there. So just to see, here's a case where we had it up to full blue. You can see this big blue spike here. We were over 6,000 kelvins, 80 CRI, about 50 foot candles. Then if we go to a warmer color, this is about 3,000 kelvins, much bigger spike in the red and the yellow. Again, still about 80 CRI, still about 50 foot candles. So we're able to maintain light levels as we shift the color. But we actually had regular daylight. We had these solitubes in there, so we could bring daylight into the space. Again, high, almost 100 CRI, color rendering index. It was, in this case, it was a little bit lower light level, about half the light level. So it's not a perfect analogy, but what I wanted, part of the purpose of this slide was to show that out in the parking lot, even on a cloudy day, so this was taken during a cloudy day, we had over 600 foot candles. So with a high CRI, obviously, almost over 5,000 Kelvin. So, daylight is something that's much brighter. And, I think it's the jury's out as to whether we can really get electric lighting to take the place of that. We look at historic factory buildings, and this would be true for schools or even offices. They had tons of daylight, and the reason was because they had to. They didn't have electric light sources that were particularly effective. It's a little hard to get a sense of the scale of this building. Here's a regular doorway. This is a big institutional door, probably a 9-foot doorway. So these are enormous windows. and it's a relatively shallow floor plate there, so that you can see it's very high windows, daylight from both sides, really well daylit space. Same thing here. This is a bigger, more massive building, but there's probably a big courtyard in the middle of this. Again, giant windows. Look at the size of this big doorway, and then these windows are huge. So these were daylight driven, and up until, you know, up until say the 1950s, most of the interior spaces were daylight driven. I will say back then in the day, in the winter, it was chilly in there, and in the summer, it probably got pretty hot. So we really had a connection to the outdoors, for good or for ill. There is a ton of research going into finding out whether we can have electric light stand in for daylight, or what the effects of the electric light are, whether or not we are trying to mimic daylight or not. You know, it's like I say, it's been almost barely 3 generations since we've started having electric light dominant in our workspaces. And we know that it affects our circadian systems, it impacts our sleep. There can be health issues and psychological issues associated with some of these electric light sources. And like I say, we just don't know. Our circadian rhythms, you know, we see people in warehousing sometimes 3 shifts, or even 2 shifts, people working well into the evening. And we know that light stimulus affects all of these circadian functions to one degree or another. You know, I mentioned that we had 600 foot candles out in the in our parking lot on a cloudy day, and we were getting 50-foot candles from our color-tuned electric lighting systems in the classroom. So maybe that's not enough light to really make a difference. Maybe it's not affecting us, or maybe it is. Like I say, it's more research is going on, and we're finding out more things as we do the research. So, you know, in this, just recently, in this century, 2002, we identified a new photoreceptor in the human body. It's like we found another finger or some bone hidden someplace that we didn't know about. And it's really not part of our visual system. So we've been doing research and this photoreceptor doesn't play into our vision, but it does affect the messaging that's going on with our glandular systems and our brain functions. So learning about that as time progresses. One thing we know about this new receptor, in fact, it's called the intrinsically photosensitive retinal ganglion cell, the IPRGC. That's a mouthful. Slow response, so it takes a little bit of time for it to affect. It has to do with you know, pupil size, and again, it can affect melatonin levels. So some of these stimulus variables, we talked about time, we talked about intensity, distribution of the light, the spectral power distribution, and then the duration, as well as the timing. You know, it's a little bit like if you had a little bit of chocolate, you know, right after dinner, that might be one thing. If you had a lot of chocolate right before dinner, you might lose your appetite. Maybe it wasn't chocolate that you had, but maybe it was some other thing. So again, the intensity how much light is incident on the eye, foot candles, and we're also wondering, where is it approaching the eye? If most of the tasks people are seated, like in a classroom or an office, it might be one mounting height or one height that we're interested in. But if people are standing and walking around, it might be a little bit higher, where we'd be concerned about where the light is. The distribution. What direction is the light coming? Is it from overhead or is it from a lower angle? And that may be a function of the geometry of the space, where the fixtures are physically hung, and a whole range of things. Does the space that you're in have a lot of windows, let's say, or are they skylights? The distribution and the direction. And then, of course, spectral power distribution. So we look at incandescent light sources, and we see lots of red dominant. We look at some of the LEDs, and we see a lot of blue. We look at some of our older historic, say, fluorescent sources, and we see gaps. We look at daylight, and none of these really look like daylight. So how big a difference does that make? We're really not sure. It may be very important. There's some people who say lumens are lumens. So, it's more of the intensity and the timing. Others are very concerned. Is it red light? Is it blue light? And then the dose and the duration. So you might be working in a space where it's mostly subdued lighting or some other kind of lighting, and you're only periodically going into the bright area, and then you're going elsewhere. So, there's lots of factors here. And lastly, we look at timing. So when are you subjected to these bright light levels that are maybe blue dominant? So after work in the winter, you go to a big box store and you spend an hour there. Well, maybe that's not a great plan. Maybe you should have done that during midday and then gone straight home after work. That's not always possible, obviously. So some of these get to be questions about how our society is structured. Is it fair to have a night shift? I mean, in some cases that's not. We're used to our Amazon Prime, where we're getting things within 24 hours. Well, okay, that means somebody's got to be working all night. We see this in healthcare. We're used to going shopping, to Target at 9 o'clock at night. So again, we get into structural, societal changes, perhaps. So here we have it, the intensity, etc. If only we had a convenient way of manipulating most of these variables, like intensity, spectral power distribution, timing, duration. Well, we can do all that with our advanced lighting control strategies, and with LEDs and controls, things are coming together about the same time. So, obviously, there's things that we do know. We're not completely in the dark here. Research is going on. There are things we know that we don't know, and I'm starting to sound like a politician here, but we don't always know what we don't know. So that's the biggest area, I think. We, up until this century, we didn't know about the IPRGCs, right? So we're finding out new things. All right, it's quiz time. So some of the key light stimulus variables are intensity, spectral power distribution, duration, latitude, or timing. What have we got?
People are voting. And while people are clicking the little boxes, Eric, we have a question from David Summers. You want to take a listen to that right now?
Yeah.
Okay. He wanted to know how we should accurately predict the energy savings on smart high bays when there are so many variables. What are some of the best strategies?
Ooh, okay, great.
Yeah.
I'll answer that when I get back.
Okay. I think probably people have had enough time to vote. It's been about a minute, so I'm going to close the poll and share it. There we go. And Eric, is there on your right-hand side in your menu, is there an audience view tab or attendee view?
On my control panel?
Yeah, because I think you'll be able to see the results if you find that little tab. If not, I will just
Yeah, I'm not
tell.
gonna.
Yeah, 100% voted for intensity. Everybody remember that one. 92%, only 92% clicked spectral power distribution.
What?
100% got duration and dose.
Yes.
17% latitude.
Uh-huh.
And 83% timing.
Okay. Well, everybody did good. Latitude was thrown in there just as an X factor, although I could see how you might think that might have to do with, whether you're up in Iceland or down in Hawaii. So, but right. So the variables are that was the little X factor there. I seem to have lost my pointer. I'm gonna try clicking it. Oh, there we go. All right. I'm going to also pick up the pace a little bit. I see we got a lot to cover and we're running out of time. See if I can advance things. Okay, not able to do that. Stand by. Put that over there.
Were you going to save David's question for end of
class? Oh yeah, there was a question, about how to anticipate what the savings will be if there's so many variables. And I think probably the best thing you can do if you have an existing building and you are putting in new lighting and or new controls, so it's a big old retrofit, is to do some data logging, get some data loggers and see what your occupancy rates are. These data loggers can log the amount of daylight coming in. If you have existing skylights, all of those things you can predict. To some degree, it's going to be a little bit of an unknown, but that's probably your best bet. If it's totally a new building, then you just have to go with what the norms are for occupancy, and we'll touch on that actually on one of the later slides. So that's a good question. All right. All right, so hardware. Let's blast through some of this stuff. Yeah, and I just wanted to mention. So we've got manual controls down to the space age with our controls. One thing to keep in mind also is parallel to this, we've gone from light sources that were fairly difficult to control to LEDs now, which are fairly easy to control. So if it wasn't for some of these new light sources, we'd probably be still having trouble. Like if all we had was metal halide still, some of this stuff wouldn't be possible. So we have line voltage switch, three-way switches, contactors, wall box dimmers, preset controllers, zone control wireless, all the way down to the Internet of Things. So lots of things to work with out there. Why do we do this? Well, one is to increase flexibility, productivity, user satisfaction, maintenance, There may be lead things or well building that we're looking at, energy savings, energy codes, staff wellness, and aesthetics. And aesthetics may seem trivial in this case, but honestly, this can feed into these other things where if people walk into this space and they see that everything's lit properly and it looks like there's controls that are functioning properly, it gives people a sense that they're in a modern facility where things are going well. And so I think that shouldn't be overlooked or trivialized. People pick up on these things. All right, so let's look at some scenarios. Typical warehouse, if we just went with regular, kind of last century controls, we would have photocells on the parking area, so the lights would come on in dusk and go off, burn all night long, and go off at dawn. We probably have one big switch or a contactor someplace where when the first guy came in the morning, they'd turn on the lights and they'd be all on all day, maybe until the end of second shift. We have an office area, someone would walk in there, they'd turn the lights on, they'd just stay on. Restrooms would probably have occupancy sensors, let's just say, little restrooms here, and the break room would probably have an occupancy sensor, although not necessarily. And that would be it. Let's look at what we might have in this modern age. All right, so now we've got photo controls in the parking, but we're going to zone them. We've got one zone here for our shipping, one zone here for receiving and some staff parking, and then another zone here for staff and customer parking. And these would be photo controls. And possibly a time clock. Oh yeah, in case, so with our modern approach, they'd be a photo cell and a time clock. And then interior, we'd have photo cell in the break room. There's some windows here. Our receiving area would have photo cell, and then the office would have a daylight zone here, going about halfway into it, a little over halfway into it. But if we look closer, we see that there's skylights in this building. So now, in days past, we wouldn't care. They'd just be there, and as the day progressed, lights, the daylight would come in, but the regular lights would just stay on. But we can't do that these days, and maybe we don't want to do it. So, but for our skylights, Washington Energy Code says that our daylight zone extends about 0.7 mounting height percent of the mounting height out from the outer edge of our skylight. And we're just going to assume that the mounting height, the geometry of the space is such this whole area becomes a big daylight zone with side lighting and top lighting. So that's our daylight. Now let's look at occupancy zones. Again, instead, all we had before was occupancy sensors in the restroom areas in the break room. Now we've got separate occupancy zone in shipping or receiving. We've got this open area. We've got each aisle is a occupancy zone. We've got the office here, shipping and receiving office is one. We've got some other functionality there. We've got the office is one occupancy separate from the foyer. And then we also have exterior. So we have our occupancy here at this little parking lot and occupancy here on the customer employee parking. And a possible sequence of operation might be something like 10-minute minimum of 10% during regular hours for the interior, unless 3 times daylight. Daylight is 3 times the target. The aisles go to 85% upon occupancy for 3 fixtures around the activity, task tuning. The back aisle, this little area here, goes to 50% upon any aisle activity to mitigate contrast. And then egress fixtures go to 110% upon egress event, whether it be power failure, fire, earthquake, or whatever, due to lack of contribution. And what are the egress fixtures? Well, they might be something like this. So we've got egress fixtures here, or lighting rather, controls, maybe a little bit in each of the aisles. We want people to linger in the aisles, but so that they're not in the dark and they can find their way to the exits and the exit. So you combine all that and it makes for a very complicated and complex control zone pattern. But not all is lost. We have network lighting controls to the issue. So let's go through some products here. We're not going to spend a lot of time, but I wanted to introduce you to some of the players. There's a lot other ones out there. So here's one by Cooper, by Signify Cooper, repped by CTEC Lighting, and it's their wavelength. It is a wireless. They have multiple flavors of this. It can be wireless or wired, or it can be a light variation. So you can have the wired system might look something like this, where all these input devices feed into a network. And then there's even actuated setup touch screen there. You can do wireless as well, or combination feeding in. Appropriate for all of these kinds of applications. And here's a scenario. Here's a LLC product that they've got by Metalux with a sensor built right into a high bay fixture. And it might look something like this, where you've got unoccupied space and it's occupied. Here's our 100%. Because of daylighting, we've got it down to say 70%. After someone leaves the space, it maintains for a period of time, then it steps down a little bit. In case there was a false trigger off, people can make adjustments. They're not in the dark, and then it could go off all the way, and then it might come back on again. They work with, in the Spanaway area, one installation they've got in a fairly large distribution facility. Some of you might recognize those colors. The goal of the project was to provide a low maintenance, easy to use solution that would save quite a bit of energy compared to standard time clock control of the space. Okay, here's a pop quiz. What are some of the common control strategies? Interior occupancy vacancy, passive aggressive, daylight harvesting, task tuning, and exterior occupancy.
All right, while people are marking their choices, obviously passive aggressive is one. I'm just going to give you a hint. Kind of in response to David's question earlier, Eric, Sean wanted to remind us that the DLC has recently released an updated report characterizing potential energy savings for controls. That might be something people want to take a look at. And David kind of had a follow-up asking if you have a recommendation, or maybe Sean wants to chime in too, on a data logger that can accurately predict daylight.
Well, predict daylight or measure daylight?
Well,
so,
maybe a little of both, yeah. Measure,
well, we'd have to measure.
David responded, measure, yeah.
I mean, Hobo is one that gets used a lot. That's the brand. So, but maybe, yeah, in the interest of time, we'll take that one offline. But I think if my audio is still on, Hobo is one that gets used a lot. And maybe we can contact myself or Sean later.
Yep, we can hear you.
Okay. Okay. Time to close the polls.
Oops, I was still muted. Yes, here we have the results. Everybody voted for interior occupancy and vacancy. Everybody voted for daylight harvesting. Almost everybody voted for task tuning. Nobody took the bait on passive aggressive, even though they just didn't trust me. And 33% checked exterior occupancy.
Well, I guess that's it. I'll give you that. It's not common now. That's true. Exterior occupancy would not be considered common, but it is something that we're looking at and shouldn't be ignored in a modern network control system. So, all right, moving on. Hubble has a series of products, or in this case, it's their NX distributed intelligence system, repped by Pacific Lighting Systems. And again, we have a wired version. There's a wireless version and a hybrid that allows combination of that. It can work with both Android and iOS apps. And that's kind of important. Keep in mind, not all of these little downloadable apps or can work with across platforms, or even some of, as we'll see on some, they're only available with certain types. So you may be running around trying to find an iPhone someplace so you can get the thing to work. They use their DNA, distributed network architecture. I don't know if anybody's seen the movie The Matrix, but yeah, it's happening. No, they use distributed network architecture, so each part of the system always knows what its role is. Apparently, does not need. You can do entire campus without central processors or gateways. Although I suspect those are an option if you want to deploy those. Flexible, easy to design with for industrial and outdoor venues. Here's how a system might work, where you have wireless in one area, you've got maybe a wired strategy in a different area, and then you have a hybrid in yet a third, all of these feeding into your controller and can be adjusted or monitored remotely or locally. They have their PEL is by Columbia. Again, platform with built-in controls, LLC. Here's one by a company called Digital Lumens. As the name suggests, they do digital fixtures, LED fixtures, so-called. And their SiteWorks platform has SiteWorks Sense, SiteWorks Area, and SiteWorks Tune that has different flavors of monitoring. The SiteWorks Tune uses typical occupancy, various sensor inputs, as well as manual inputs. The SiteWorks Sense is interesting. So you can put sensors into the machinery and detect changes in temperature or vibration that can feed back into the network. You can look at some of your utility, local utility usage, steam, wastewater, etc., and see how things are going, as well as looking at the environmental conditions in the facility beyond just light levels. You could be looking at temperature, humidity, decibel levels to meet health and safety standards. So it's pretty complex there. And then the SiteWorks Area, you can look at usage over time and see where you're, how to configure perhaps your floor plan, track assets, and you can look at people, equipment, and goods and see where they are, when they are. And I should say that probably most of these systems that we look at, except for the real basic ones, would have some provision for this kind of thing. It may be a third party that you're working with, or it may be part of the a more developed system. But they just had this on their website, and I thought I'd mention it. And then they also have their series of luminaires with sensors built right into them as an LLC product. Here's one I hadn't heard before by H.E. Williams, rep by Electrical Reps West. It's their Link T Air wireless controls. And, you know, you can have a mobile app. It uses iOS only, although you might want to verify that, but that's all they say on the website. But you can have, it'll work with either sensors, fixtures with sensors built into them, or sensors, the fixtures themselves would be, have the radio controls, and they could talk about their status, and they could also have sensing devices or separate sensing devices. Here's a situation where you can see a floor plan, the different zones, and you can get them set up at the factory so that you just have to put them up and you declare which they are. And this would be true probably for the other manufacturers. One thing to check, so this product gives coverage up to 40 feet. And there were some products I looked at whose sensors couldn't handle these high mounting heights. So that's something you need to check. It may just mean that you need to use a third-party sensor rather than the one that you get, but just be aware of that. And they have their GH product with the sensor built right in. Cree partnered with a company called Synapse to create their Simply Snap on-site controller. And again, does a lot of these other things, but one thing I thought was interesting, it has a mesh that can connect up to 1,000 fixtures to a controller up to a mile away. Not sure how big the warehouses are going to be, but they do get large, and so distance and quantity of fixtures does become a factor. I think on a project that we're going to look at in a minute, they had over 3,000 fixtures in their facility, so it adds up. And again, they've got daylight harvesting and then control, programming and controls, and security is something that you'll see most of these manufacturers at least talk about, but it would be worth checking to see how they deploy that security. Here's a case where they were working with a large manufacturer. Here's you can see on their KBL fixture, they've got the controller right there. And here's a case where they partnered with Uline, and yeah, they had over 3,000 fixtures, almost 1 million square feet of warehousing. Excellent savings. Interesting, only 5% daylight savings, and I think that might be a case of where how they had their settings. So here's from that same project. You can see the skylights, pretty bright area. So if they had been a little bit more stringent on their daylight, they might have gotten a bigger number here. And of course, from Acuity, we have Enlight. Lighting controls platform is distributed digital platform, time-based, sensor-based, and manual inputs. Again, this is from obviously a conference room, but you can have wired or Enlight wired or Enlight Air, wireless controls, different input devices. And it can function in a single space or campus-wide. Most of these are products that we look at are scalable. It's just a case of how scalable. And another thing to look at is if you're looking for a campus-wide type of control system, it doesn't hurt to have a manufacturer that has a full suite of products that can accommodate a whole range of spaces, so you're not having to bring in other parties necessarily. And that's repped by the lighting group. Here's, and from the Nlight series, one of my personal favorites is the high bay, the IBG, or as I like to say, the notorious IBG, and it's coupled with internal controls for a full LLC platform. So considerations. One thing we focus on a lot is energy savings, but honestly, you really have to look at ease of operation, ease of maintenance, and ease of installation. If these things don't happen, one, it's not going to work right. And so that'll affect worker productivity, worker safety, worker well-being. You know, these are bottom line issues that far outshadow any energy savings you might get. This is the owner's primary concern, and this should be your primary concern when you're specifying these products. The savings is great, and that'll happen if you have these things. Can't stress that enough. You know, and all of these even fixtures that LLC systems that out of the box are supposedly ready to go, they're going to need some kind of commissioning. And another big piece of that commissioning that often gets overlooked is education, i.e. commissioning of the occupants. You know, they need to know what's happening. Why are the lights dimming? You know, why does it look dim over there and bright over here? Do I have to hit the switch when I walk in to turn the lights on? All those things will get buy-in from this group who can make or break the product performance. So sequence of operation, whoever winds up doing it, whether it's the contractor or a startup technician, a factory person, or a third-party commissioning agent that you hire, you know, you need to know all of these things. A lot of times people say, oh, we just want daylight dimming. Well, that means a whole lot of things, and it can mean different things to different people. So it doesn't hurt to really spell out what exactly are these various things and how are they supposed to function. Okay, so here's another pop quiz. The more important than energy savings, which are the key considerations for a successful control strategy? Ease of operation, ease of maintenance, worker productivity, worker salary, worker safety. Let's go to the polls.
All right, we are collecting responses, and just wanted to point out that Sean sent me the link to the DLC article that he mentioned, and I posted it in the chat for anybody who is interested in following that link.
Excellent. Thank you, Mr. Dara.
And it looks like people have stopped submitting, so I'm going to close the polls. And okay, we've got everybody voted for ease of operation.
Yay.
Almost everybody chose ease of maintenance.
Mm-hmm.
And same with worker productivity. Nobody took the bait on worker salary.
Hey, that's the most important.
And just about everybody chose worker safety too.
Excellent. All right. Couldn't fool you. All right. Well, I like it. I like it. All right. So we talked about LLLC, high granularity. So let's look at some traffic patterns in a facility and see what we might be what we might be looking at. So let's say it's nighttime. Second shift has gone home. Parking lot is down at 30%, still lit but dim. Inside, these egress lights are glowing at a 10%. They're just sort of barely there. And the business is closed. All right, someone walks in, first guy there, early entry, it's still dark out. The ambient goes up to 30%. The lights, he walks in the parking lot, goes to 90%. He pulls in, and bright lights there. Not here, just here. And the traffic pattern everywhere this person goes, actually it's a she. She walks in, goes into the lounge, walks over to uses the restroom, and goes. She's the shipping and receiving manager, and so now she's doing some paperwork. Okay. And now someone else arrives, and they go in the front door. Now notice the parking lot is down to its 30%, but this one's up to 90%. This whole area is still at 30% ambient. It's just sort of glowing, but not dark. Still bright in here, they're still there. And now this person's come in, they've gone to their cubicle, they went to the bathroom, and those areas are at 90%. The break room lights have gone off, let's say. Okay, now our business is open. Before all this was before business was open, but now business is open. It's early morning, parking lot lights are off. Ambient is up to 50% during business hours. Occupied areas are at 90%. So some people have gone down some of the aisles, people have used the restrooms, the office is fully staffed. And so people are working in product coming in, product going out, but really not much in this area. So that's another scenario. And now it's midday. Earlier it was cloudy, so the skylights weren't active. But now it's midday, so the daylight areas are off. The ambient areas are at 50% where there's no daylight. Occupied areas are at 100%. Someone's still in the bathroom. Yeah, so there's quite a bit of savings there. You compare that to that scenario we had earlier where, just someone coming in and turning on the entire warehouse. The parking lot was lit all night long. This is a pretty different situation. People sometimes say, geez, these controls are expensive. But, compared to the cost of installing a wired system, where you've got lots of labor, you've got some repairs to do, the cost of the materials might be less, but you look at the overall cost, and it's a different story. Considerations with wireless systems are, of course, obstructions that you might have. Certain materials, the controls can go right through them. Other materials, it's a lot harder, or it might vary depending on the amount of rebar you've got or different things. So you want to check all those things out. Security is a big deal. It's still a big deal. It's going to be a big deal for a while, but the manufacturers are getting smarter about putting in interlocks and things that keep, sometimes it's a case where you set up the system with one type of product, and then once it's set up, it's a different kind of communication for operations. Flicker can be a problem in any case, and it can be a big problem sometimes. flicker or what we call temporary lighting artifacts, you know, it can be easy, it can be okay. Sometimes it's not an issue. Sometimes it's kind of annoying, but it doesn't really matter. People aren't in the spaces that often. Sometimes it's hugely annoying, other times disastrous. You know, rotating machinery, it's a little hard to show a picture of a rotating machinery that looks like it's not rotating, but we can have a case where you've got strobing effects that make a piece of rotating machinery look like it's stationary. Obviously, there's a big potential safety hazard there. So there's new studies coming out and new requirements on that. You can check it out at this link. You know, is it flicker, flutter, shimmer, shutter? You know, different products are going to behave differently. It's a function of how much it's doing it and what's the frequency. And as it gets to be a high amount and a relatively low frequency, it becomes more and more of a problem. If it's a low amount and a high frequency, it's really kind of there's not much of an effect. Where do we go from here? We'll take out our crystal ball and look at things. So we've got the Internet of Things, whether it be HVAC systems, room scheduling, communications, tracking, security, your refrigerator. What else might be? We're connecting all of these things through the internet, through the cloud, and ultimately it's going to make life easier, but there's going to be some hiccups along the way, and we just need to kind of hang on. Asset tracking, though, is something that is more and more becoming a factor, and lighting makes a great platform to put these sensors because they can really see into pretty much every space where people are because there's always lighting there. And so you can put trackers on all kinds of pieces of equipment and even personnel if you need to know where certain people are for safety or productivity. Here's a little case study. Signify, used to be called Philips. We're partnered with Interact, so they acquired Interact, and they put in a large automotive warehouse in where they put asset tracking in there. The sensors relay information about warehouse usage, conditions via Zigbee wireless system, and they can track all kinds of information about the products and how things are flowing. Li-Fi, so-called, you've heard of Wi-Fi. Well, Li-Fi is light communication. Sort of the promise is that our lighting fixtures would transmit this information. It's probably not going to be the case anytime soon that we actually have the white light emitters transmitting the information. It's probably going to be a separate light source, maybe infrared light source that's embedded in the luminaires that can then pick up information or transmit to say a laptop or a handheld device. And that in some ways that could be more secure than coming through a Wi-Fi signal. And in the case of Li-Fi, it requires line of sight, so that makes it in some ways more secure. If someone can't actually see it, they can't capture it. There's potentially a lot more bandwidth. There's a lot of promise, but it's still early days, and there's some technical problems with the technology. The kind of network lighting controls and LLC systems that we've been discussing are excellent fit for both new construction and existing buildings. no additional wiring or sensors to install. So that's pretty good. You just install the fixtures and it's ready to go. You just have to program it from below. Some of you might have heard the 1990 rule in computer programming. Well, that might even hold true for our controls rollouts, where we have a low amount goes to energy and resources, then the space and layout, but we get a big payout here with productivity and wellness, which leads us to 100% revenue opportunities. And I think our final pop quiz is flicker from lighting might be, and that's not A-okay, it's just A-okay, might be mildly annoying, and that's not B mildly annoying, it's B mildly annoying, hugely annoying, disastrous, or all of the above. And I think we probably don't need a lot of time. Well, and one thing I would say, it wouldn't be all of those at once. So it probably wouldn't be okay and a disaster simultaneously. So don't be fooled there. But it might be all of those at any given time.
Okay, I'll just give another second and close because we're running short on time.
I know.
1, 2, 3, or maybe 3, 2, 1, close. Okay. And it looks like a few people checked okay. A few more checked disastrous.
Yes.
A few more checked both mildly annoying and hugely annoying, and 70% checked all of the above.
Right. Okay. Well, good. Maybe it was a confusing question, but at any rate, you get the idea. It could be all of those. All right. So benefits of plugging into utility territory. So guess what? Your utilities want to help you put these controls in. They see the advantage, they see the benefit, and so they want to help, and they can help help you invest. They can provide technical support, tools and resources, access an encyclopedia of implementation and knowledge, access impactful programming. And one thing I should say that's helpful is if each facility or each company has a sort of a utility cheerleader, if you will, so they can know what the various utilities provide, what they do, who to contact. It doesn't hurt if you've got an advocate in-house. All right. So for instance, design considerations, savings and incentives. So example is in this case is Cindy Light's program, space use type. So someone asked earlier, how much savings can you get by using these controls and how to predict it? And they predicted that these might be the savings that you would get if you use network lighting controls, if you use Luminaire level lighting controls. Some of these numbers are increased a little bit. So they're willing to predict higher savings in addition to often providing an additional incentive. So check it out. We've got some guides to help you, NLC and LLC best practice guides. We've got the video. If you haven't seen it, it's amazing. Armando is like a rock star. And then you can find those on our website. We also have a couple other guides. Here's a warehouse controls guide. Talks about modern controls for warehouse. And here's network lighting control systems. And you can find this on our website. Go to resources and lighting guides. And there's a few other things there as well. Late breaking news, there was a study recently completed by NIA. They didn't do the study. They partnered with the University of Oregon. They funded the study. U of O did it on Luminaire level lighting controls versus a regular redesign. And it's a pretty interesting. It's not really long, so I recommend you check it out. Some additional resources that might be useful. And thank you very much. Any of you who might remember, my old lab Stella passed away about a year ago, so now we have Olive. Welcome, Olive. Any questions? I think in the interest of time, I'll let Katie take it from here, and you can contact me later if you have questions.
Okay. Yes, thank you, everybody. I know we are over time a little bit. And did you advance the slide, Eric? Eric just hasn't.
Oh, please. Yeah, there we go.
Yeah, sorry. This is, we have a new date for the NLC for schools. It's December 8th. I will fix that and make sure that the handout that goes online has that new date, but it also, if you go to register for it online, it says December 8th. And if you could advance the slide, there's Eric's email if you think of anything after the class. And you can always email at us at lightingdesignlab@seattle.gov. And we will, well, I will post this video and handout within the next few days. And speaking of plugging into your utility, Bonneville Power Administration, Chelan County PUD, Tacoma Power, Idaho Power, and Snohomish County PUD all support Lighting Design Lab this year. And next slide, that is all, we made it. Thank you again, and make sure you take the poll that pops up as soon as I close this webinar. Anything else, Eric?
No, thanks again.
All right.
It's been a pleasure.
Have a good day, everybody.